second. Okay. Excuse me. So this section that we're working on is focused on quadratic, both equations and functions and graphs. They are all interconnected and very similar to one another. A quadratic equation would look like ax squared plus bx plus c equals 0. And we've already done some work with those quadratic equations. A quadratic function would look like f of x equals ax squared plus bx plus c. Okay. So a function, right, is a relationship between an input x and an output y, right? So for different x's, I get different y's. An equation is a statement that these two things are equal, right? And a statement has solutions, right? And we know from quadratic equations, we often get two solutions. So we're kind of exploring and seeing the connection between those. And first, we want to start off just by making sure we know how to solve quadratic equations. In the past, we've factored these, right? And that is still going to be a good approach moving forward as well. If you have an equation like x squared plus 9x plus 18 equals 0, that's a quadratic equation that we could have seen before. And hopefully your instinct is to factor that and set each of those factors equal to 0, giving us those two solutions. Always a great solution. Okay. The problem for us is that sometimes factoring is pretty hard, right? If all of a sudden this is like 54x squared plus 9x plus 18, now all of a sudden I'm kind of in trouble. Like, I don't know if I can factor that or not. And it turns out there's a lot of quadratics that actually aren't even factorable. For example, what if we run into x squared plus 5 equals 0? Well, we don't have an easy or sort of standard way of factoring that like we could this one here. So we're a little bit limited if we just have factoring. And so the first part of this section is going to introduce some new techniques for solving quadratics. And the first technique has to do with ones of this form, which we can solve using something called the square root property. Okay, and the square root property says that if x squared is equal to a, then x equals the square root of a, or x equals minus the square root of a. There's a little bit of subtlety here in that a lot of students will kind of make the error and say, okay, x squared equals a, I'm going to take the square root of both sides, and that's going to give me x equals the square root of a, and that's going to be my solution. And technically that's not correct, because you would miss this whole other solution, right? Half of the problem. So it's not that it's really like the wrong way of thinking, but that property just doesn't work. You can't take the square root of both sides. You can multiply both sides by 2, you can add 15 to both sides, but you can't actually just take the square root of both sides, because you miss this negative solution. So that's why we get this square root property. So it will all be fine as long as you remember when you take the square root of both sides, you have to get the positive and the negative. And so often we write those together plus minus the square root of a, just because we're all a little lazy. That won't be possible when you put it into my math lab. You just have to write each of them separately. But if you're doing, take-home quiz or the final or whatever, it's fine if you write plus minus for me, right? We know that's two values. So be warned about that. It's a very common error, and it is incorrect, and you'll lose some points because you're missing some answers unless you get both the positive and the negative. Okay. So the square root property actually is even better than factoring when it works out, because if you can get it to look like this, you can get your answers kind of immediately, right, using the square root property. So this example we had here, x squared plus 5 equals 0. Well, I just have to do a little bit of work to get it in the right form. The square root property says this is plus or minus the square root of minus 5. Square root property. You don't have to write that every time. After you get in the right rhythm, you'll just do it naturally. And there's no problem with square roots and negatives now, right? After our idea of complex numbers from the last section, we know that this is really plus or minus I square roots of 5. And those are the solutions to this problem here. Okay. You can use it even if the problem factors, of course. This one factors x plus 2 and x minus 2. So you get those two solutions, x equals minus 2 and 2. And of course, you get the same thing by moving the 4 over and then using the square root property. Okay. So just so we're clear, right, these two methods are both effective, and they're going to give you the same answers because those are the answers, right? Plus 2 and minus 2. But you can't forget the negative. And you should be looking for it, right? Every time you do a quadratic, you're really looking for two answers. Sometimes those two answers are the same answer, so you kind of end up with one. But other than that, you're always going to get two answers to these. Now, that's pretty nice, to be honest, but kind of like limited, right? Like there's only a couple of different types that might look like that, but it actually can apply to some more complicated looking expressions as well. Like here's one. If you square this, then you have to FOIL it all together, and you get this kind of big expression equals 7, and you can rearrange it and get a quadratic back in our standard form, all the way back to here, right? That's our standard form. But my goal is to solve it, actually. And the way this one's written, I have something squared equal to 7. So I can actually use the square root property here too. The something, which is now 2x plus 3, has to equal either positive or negative square roots of 7. And it's nice to write and keep plus and minus here, because otherwise I have to just do almost exactly the same thing. Right? I have to do a plus 7 and then write it all over here with a minus 7 and do the same work, right? And the work here is just to get x alone. I'm going to subtract a 3 and divide by 2. Right? And then I would have had a 2x, so I divide everything by 2. And it may look sort of messy, but that is a answer. Is just like before. These are two values. each of these values, when I put them in, will make this equation true. So visually, this may look different to you than this one, but actually they're really the same problem, right? Something squared equal to a number, the square root property applies, which gives us, right, what we're looking for. All right. Here's one more. Now, if I had given this to you 20 minutes ago, I would have expected you to add the 2 over to here, giving you x squared plus 6x plus 11, and then you would try to factor that. But you would fail because that doesn't factor. X squared plus 6x plus 11 doesn't factor. So that method or that approach, while not bad idea, doesn't work. It also doesn't quite look like this one here, right? It has an x squared, but you need the whole variable, this sort of whole thing squared, to be equal to a number. And if I move the 6x and the 9 over, when I square that, or square root that, it's going to get messy. It's not going to be just a number. So as it's written, it's not quite in the form that I need. But you might notice this left side, I could factor it. And normally, factoring, we need it to be equal to 0 in order to factor. And that's still true in general. But this one is going to factor in a very specific way. It's going to be x plus 3 times x plus 3. And you want to recognize, that's exactly like this last problem. That's really what we call a perfect square. Get another color here. I don't have another color. Perfect square. I'll put a little exclamation point there. Perfect square. And that's great, because since this is a perfect square, I can now use that square root property. X plus 3 equals plus or minus the square root of minus 2. I can bring the 3 over. Negative 3 plus or minus I square roots of 2. Out of room on my whiteboard and my sheet of paper. So you should be thinking to yourself, well, that was pretty lucky that it happened to be a perfect square. And maybe you're also thinking to yourself, well, that wasn't even lucky because he made up that problem, right? And I did. I made up that problem so that it factored just like that, right, as a perfect square. But it turns out you can also kind of make those problems work the way you want them to. So let me give you another example here. And you know, this strategy kind of goes back to hopefully your new thinking about math, which is that if you see things you don't like, you can change them, right? We have the power to change and adjust our problems, not just randomly, right? But according to ways that keep the solutions the same, right? Adding things to both sides and these different strategies here. So again, when you look at this one, your first thought would be to factor, but it doesn't factor, right? The only factors of 5 are 1 and 5, so there's no way I can get those to be 8. And also, I think you can see, you know, since it doesn't factor, it's not going to work exactly like the last one, right? It's not a perfect square. But it'd be really nice if it was a perfect square, right? Let's see if we can make it a perfect square. This 5 actually is kind of in the way. I'm going to move it over to the other side, which makes it look like this. And now what I'm going to do here is I'm going to add something to both sides. And this strategy is called completing the square. And I want to add just the right thing so that this left side is going to factor as a perfect square, just like the last problem. And I'll write down the last problem here just so we remember it. X squared plus 6x plus 9 turned into x plus 3 squared. Give you another one. X squared plus 10x plus 25 turns out is going to equal x plus 5 squared. And you can check that, right? That's x plus 5 times x plus 5. X squared plus 10x plus 25, right? The way that foiling goes together. So can you guess what I should add here? This is our chance to sort of make the problem the way we want it, right? A dream situation. You see the pattern here? The 6x and the 9 became x plus 3. The 5x and the 25 became x plus 5. So if this is 8x and 16, I've got to do the same thing to both sides. This is great, right? This is just what I want. X plus 4 squared. And notice what we've done here is we've taken a unfactorable, potentially unsolvable problem for us, and we've turned it into something that's equivalent but can be solved by the square root property. So this is a good step for us because this strategy is giving us a way of solving problems we weren't able to solve before. X plus 4 equals plus or minus the square root of 11. X equals minus 4 plus or minus the square root of 11. Questions on that strategy? Well, thank you. That's a nice compliment, I think. I do probably make it look easy because I do it a lot, right? And I've done it a lot. And certainly, I think you're probably imagining like, well, okay, that seemed easy, but when I go home and try and do it on my own, I know it's not going to go quite that easy. And you're probably right. But this one actually, it's sort of a one-trick pony in that there's really only one tricky part to it, which is kind of figuring out what goes here, okay? And the nice thing is there's really a formula for that. every time you're going to take half of this coefficient and you're going to square it. That's what goes here. And if you do that, you'll create a perfect square. And that perfect square we can solve using this strategy. So there are some steps here, but like to me, the crux of the problem is going from here to here, right? If I can change this problem to this perfect square problem, right, then I feel confident I can solve it. Let's try another one. Now, you will probably see some that have some fractions in here. But you just do the same thing. So if I want to solve this by completing the square, I want to get rid of this kind of constant term that ends up being like a distraction to us. So I'm always going to move that over to the other side, you know, whether there was something over there or not already. I just want to get some space here to operate. Now, the rule is I always take half of the middle term and square it. So 5 divided by 2 squared, unfortunately, gives me a fraction, right? 5 halves. That's 25 fourths. So, you know, neither you nor I love that, but I can do it. This is 40 fourths, right? 10. So 40 fourths plus 25, 65 fourths. And then here, remember I've created a perfect square. And right, whatever this inside is going to go here. Right? Notice the 3 is half of the 6. The 5 here is half of the 10. The 4 here is half of the 8. So half of 5 is 5 halves. That's what goes here. And here I've made it to sort of this big spot where now I can finish the problem using the square root property. I'll take the square root of 65, which can't be reduced, and then the square root of 4, which can be reduced. Now, the numbers could be worse, and there are a couple other complications that you can run into. It turns out that if you have a coefficient on the front of the x squared here, you got to get rid of that. This strategy won't work if you have a number here on the front of the a squared. So you'll have to like divide everything by that. Now, luckily, there's a shortcut for us. So we don't have to do this method when we're faced with these more complicated you know, arrangements, these other versions. That shortcut that you may have seen in the past is called the quadratic formula. And it turns out that the quadratic formula simply comes from doing the completing the square method on this kind of generic quadratic. So if I keep A, B, and C in there, and I work through all these same steps we just did, when I get to the end, I get an answer in terms of A, B, and C. And so what that means then is that I don't have to go through all the steps. I can just go right to the form of the answer as long as I can remember it, right? Or have it written down somewhere. So the quadratic formula says the solutions to this are negative b plus or minus the square root b squared minus 4ac over 2a. So if you haven't seen that before, you really should memorize it. Now you get a note sheet on the final, so you could write it down too. But this is one that you're going to run into a lot. You'll run into it in your next class. It's really worth kind of filing that away so that it's at your fingertips when you need it, right? When you need to solve a quadratic. And all it tells you, it's actually a very straightforward formula. If you know the formula, you don't have to do a lot of thinking. You just have to plug in A anywhere you see an A. You have to plug in the number here for B everywhere you see a B, and C everywhere you see a C. If you plug that in, that result will give you the answers. Let's go back to this problem here. X squared plus 8x plus 5 equals 0. And let's see what the quadratic formula gives us. We know what the answer is, or should be. And so we'll just check to see that it's really giving us the same thing. So in this case, the A would equal 1, because it's the coefficient on the x squared. The B would equal 8, and the C would equal 5. Always be careful with your positives and negatives, just like always. So the solution says I take negative B, right? If B was a negative, this would be positive. Since B was positive, this is negative. Negative B plus or minus the square root of B squared, 8 times 8, 64, minus 4 times A times C, all divided by 2 times A. Notice if A is 1, I don't actually even need to put that in there because it's getting multiplied each time. So I could leave that. So this is minus 8 plus or minus the square root of 64 minus 20 over 2. Negative 8 plus or minus the square root of 44 over 2. To keep simplifying here, 44 is 4 times 11. This is why we had to do the radical section first, right? Because we needed to be able to simplify these. Minus 8 plus or minus 2 square roots of 11 divided by 2. So I can divide the 2 into both of these. And I get minus 4 plus or minus the square root of 11. And just for confirmation, right? When we did completing the square, that's exactly what we got here. Now, I did a lot of steps here. You may not have needed to do every one of those steps, but there is work in simplifying the quadratic formula. So it's not trivial. Okay, there's spots to make errors, and you have to be careful when you do this work. And you might say, well, it doesn't look like it was all that faster than the completing the square. That's true in this case because this was a pretty easy completing the square problem. But as soon as I throw a coefficient on the x squared, or make this number odd number, so you're dealing with fractions, all of a sudden, then the completing the square can be very complicated. A quadratic formula is a much better approach. The other great thing, well, really about completing the square and the quadratic formula is that they can solve any quadratic. Not if it factors or if it can be written this way, but any quadratic you can solve with the quadratic formula. It's not always the best method because we have all this extra work to do, but many times it is the only method. Okay. So my hope for you is that as we do these quadratics, that you're able to apply our kind of three main methods effectively. So just to refresh, number one, to factor. I always look to factor just a glance. If it looks terrible, I don't even try. And you don't have to, because you'll get the right answer, but it can save you a lot of energy. So number one, look to factor. Number two, look for the square root property. If it's set up for the square root property, that's going to really get you your answers the fastest. An example of that is this one right here. Right? This problem was very well set up for the square root property. If you tried to use a different strategy, it would have taken you a lot more work. And then finally, we're going to use the quadratic formula. I'm going to put in parentheses here completing the square. It's very messy, sorry about that. The quadratic formula. We typically don't use completing the square unless we are told to. And that will be true for our class as well. Excuse me. If I tell you to complete the square, then of course you got to show that work. I will only do that for problems that are relatively easy with completing the square. So not coefficients in front of the x squared and not odd numbers. A nice kind of whole number, easy one to work with. But I want you to know the process. It has other values, even though we don't need it anymore for solving quadratics. Quadratic formula replaced it. And also it is the reason the quadratic formula works. So that's also of value. So it's important. And I think it's important to know how to do that process, even if it's not what we would choose. Questions? Any questions? Yes, in terms of classes left, today is the 26th. So we also have class on the 3rd, and then our final is the 10th. So we sort of have one more of these sessions left, and then our final is taking place on the 10th. So the final is 2 weeks away from today. No, the final is going to be taken remotely. So I don't think vaccinations are far enough along for us to, or for me to be able to kind of feel comfortable having everybody in the classroom. So we'll do it like we did the midterm. And I'll be working this week to kind of get out a little review sheet for our final exam. I'll include some of the details, but it's just brief details on our section schedule. I think the time is, I think I set it up as 2 to 4 to try and kind of mirror our normal class time. Of course. Okay. Any other questions? This should get you started sort of through the first 2 or 3 homeworks. And then the second half is related to graphing, graphing quadratics. And so that's a slightly different kind of strategy or skill set. It uses some of the same ideas, but we're looking at a curve from a quadratic function. So it's a little bit like you learn to solve linear equations, and then you look at linear equations in 2 variables or functions, and then you learn all there is to know about lines. It's really the same type of learning with quadratics, right? So here we're trying to learn how to solve all the quadratics, and then we'll learn how to graph or look at quadratics moving forward. Okay.